Alright, here we are in Chapter 17, Section 4, Electric Power. Before we talk about power, power is the rate at which we used energy, usually kinetic energy. But here, power is instead the rate at which we're using electrical energy. So, let's look at our basic equation for power. Power equals current times voltage. Now, you can resolve it, and we can use Ohm's law and insert it of various ways. We can say power equals I squared R, and power equals V squared over R. But let's go through that right there just a little bit slower and say that power equals, now let's scoot that out of the way, I times V. Then we can say that power equals I squared times R. And we can say that power equals, let's see here, V squared over R. So there's your three ways of writing power equals. And that's just by substituting in Ohm's law. If you feel like doing some derivations and doing that, you can see how that works. Putting in I equals V over R and R equals IV and all that kind of thing. If you can put that in if you want, but trust me, that is how that lays out. So electrical power. Again, we are measuring electrical power in the unit watts. So, good old same watts. Watts still equals a joule per second. Or we could come up, oh, it equals volts squared over ohms and silly things like that. But we're still using watts just like we had before. And we're still going to talk about kilowatts. Let's take a moment and talk about something else that's very important, and that is how power plants work. The first basic principle is how a generator works. In every kind of power plant except solar, you have a turbine, and a turbine is nothing more than a magnet that spins within a coil of wires. So if I turn on this faucet with a trickle of water, makes the magnet spin, which generates a flow of electrons in the circuit. Okay, and make it spin faster, and of course we get more and more and more energy. Okay, so that's how your basic generator works. So whenever you're looking at a generator, this is the turbine that you're seeing. If you're talking about a windmill, that's just a wind spinning the turbine instead of water. Hydroelectric, the water power itself does it. And in all the ones in which there's things burning, coal, natural gas, and nuclear, heat, as well as geothermal for that matter, heat is used to boil water. Boil water makes steam. Steam makes electricity. So here we've got a little, it's a nuclear reactor, and here in the nuclear power plant, control rods are bundled with uranium and submerged in water. The control rods prevent overheating, and when heat is needed, the rods are lifted out of the water. What the control rods do is, remember from what you learned about nuclear reactions, when the uranium or the plutonium or whatever is, in this case, in this one, uranium, is being bombarded with neutrons, it's escaping. These control rods, what they do is they kind of absorb the extra um, neutrons that are flying around and control the reaction. So I hit play here, and what's happening is heat from the reactor boils water to make steam. Steam comes down through here, spins the turbine, just like we just talked about. That turbine then, you got hot water here. After steam spins the turbine, it's cooled in the cooling tower and converted back into just plain old water. So what we see in the big smokestacks in Avon Lake, now granted we are burning coal at our power plant, that's why the EPA wants to shut it down. But at a big nuclear plant, like if you go out towards Toledo or into the Perry power plant, that is actually just water vapor. It's just cooling it off. And that's why you see power plants near water supplies, so they have an ample source of water to do the cooling. Okay, that's just how power plants work. Now, instead of nuclear, you could be controlling with You're burning natural gas here, burning coal here, works just the same. You're boiling water, spins the turbines, and then you got to cool it all off. Notice in a nuclear reactor you got this gigantic containment structure, and you have contaminated steam. In a lot of, this is contaminated water in the red. This is not contaminated water in the blue. So, this steam that comes out is not nuclear waste. That's all within this red here. Let's go back to our notes and talk about another very important thing when it comes to power, and that is how we pay for it. One thing I want you guys to do is actually see if you can get a hold of the family electric bill and see what you're paying for kilowatt hours. See how much things cost to run them. And then you can look at your appliances and see the power rating on your appliances, and you can figure out how much it costs to run your TVs and whatnot. So, calculating cost of electricity. Power company bills you in the unit called a kilowatt hour. And what's kilowatt hour? Well, if I use 10,000 watts and I use it for an hour, that's 10 kilowatt hours. 10 kilowatts, 1 hour. If I'm charged 8 cents per kilowatt hour, how much did it cost me? Well, 8 cents per kilowatt hour times 10 kilowatts times 1 hour equals 80 cents. Notice that if you have your kilowatt hours in the denominator, kilowatts cancel, hours cancel. So your equation that you'd write would be right here. Your bill equals the cost, so 8 cents a kilowatt hour, times the energy used, 10 kilowatts, times the time, 1 hour. For example, let me look up a couple common devices. Alright, here I found a list of a variety of different appliances. And let's just look at things that maybe we have in our own homes. Let me go and do this so I can highlight here. For example, things that I would be running in my house all the time. Clock radio. 2 of those, one for me, one for Mrs. Wolf on either side of the bed. Coffee maker. Ours is a Bunn, so it's always running. Washing machine. We use a lot of laundry. Clothes washer. Our dishwasher. 2 dehumidifiers. No electric blankets. Ceiling fans. We use a fair amount of our ceiling fans. Let's see, hair dryer, she dries her hair in the morning. Heater, not really. Clothes iron, I haven't ironed in a while. Microwave, oh, very much. CPU, definitely. The monitor, yes. Radio, we use the radio a lot. Of course, the refrigerator is going all the time. Let's see, our TV, the TV in the living room. Oh, I guess that's gonna be maybe one of these 2 guys. Toaster, not so much. The VCR, DVD, I guess we could call that instead of calling the cable. Vacuum isn't running very often. Water heater, of course we all have a water heater. We all want more water in our house. So let's just do a quick little addition here of all the power I have in my house. Very rough. So 20, that really doesn't matter. Let's go with the high amount here on 1200 there. So 1220, clothes washer. We do a whole lot of laundry. So let's see. Well, then, see, just adding up doesn't work because you're also going to talk about time you're using them for. But these are just the power ratings. Now think about that. Our dehumidifiers run all the time. That's an excellent example. 785 watts. They run a lot. The refrigerator, 725. They run a lot. Let's face it. They run a lot. The TV, we can calculate how much it costs us to. Let's put 150 for our television calculation. Let's do that. If I want to watch television, let's go back to our notes here. If I want to, wait a second. There we go. That's a little better. Zoop. Resize that. If I want to watch television for an hour, and that was 150 watts, so in kilowatts that's 0.15 times an hour times 0.08. Oh, I better get out my my calculator here. File, tools, math tools, calculator. So I got my little handy dandy calculator. You can't see on the screen, but that's okay. 0.8 times 0.15 times 1, of course, equals, for an hour, it actually cost me 12 cents. 12 cents to watch TV for an hour. Now think about that for a second. That's 1 hour. So if you have the TV on from the time you get home from school, say 3 o'clock, until, let's be very conservative, 10 o'clock. Think about how long that takes you. Think about how much TV that is. 3 to 10, that's 7 hours. So 12 times 7, that's 84 cents. That's almost $1 to watch TV. And that's just in electricity alone. That's just TV. When we look at some of these other things here, power rating. Think about 1100 watts. Now, granted, you're not usually, unless you're making a big baked potato, your microwave isn't running for a long, long time. But look at this. Your computer. That's almost 300 watts alone. That's twice as much as your TV. That's in one day, people. Just think about these little things. You leave a light bulb on, 100-watt light bulb. You leave on a 100-watt light bulb. Look what that does. That's why the government is banning 100-watt light bulbs. That's 12 cents for an hour. You leave that thing on all day long, and I'm terrible about leaving the one in my basement on. And that one, granted, it's a CFL, it's 23 watts. I'm terrible about it. And the one in the garage, I leave that on too often too. Just think about these things. You are charging your family money when you do that. So now the thing you really want to know, and that is the thing that's hidden right there. So you have a homework assignment, 607, 1 through 5. And guess what? There's another one too. And that's behind this blue box here. 609, 3, 4, and 5. Alright, so you'll be working on those.